Good afternoon, everybody. Thanks for joining us for today's webinar. This is the second in the series of webinars by Atmo. Today we're going to be discussing our data-driven approach to dust suppression systems, which was part of a Innovate UK funded project in partnership with Milestone Infrastructure, and the project itself took place on the Hinkley Point C site. And obviously I'd like to thank you all for joining us today. We've got a Q&A available within the meeting itself, so please feel free to ask questions at any point. And what I'll do now is I'll hand over to our CEO and founder, Guy Barclay, to kick things off.
Lovely, thanks, Kieran. Hi, everyone. Yes, I'm Guy, I'm the CEO and founder of Atmo. For anyone not familiar with Atmo, we're an asset and environmental data company based in Bristol. As Kieran says, we've been working with Hinkley Point C on this AI dust suppression project. Really excited internally. I'm super impressed with the team, so thank you for those who've been working on this. Yeah, just in terms of what we'll be going over in the next 20 minutes or so. So we'll give an introduction to our air quality services. So you can see, yeah, we'll jump into that, and then we'll do a deep dive into AI dust suppression. So yeah, so let's crack on. So in our goals when we're doing air quality, so we want to minimize emissions off-site by identifying sources of pollution. So as well as installing air quality sensors and noise sensors and other things as well, of different flavors, we also want to understand what machinery is doing. So that can be GPS from things like front wheel loaders that are going, or forklifts that are going around site and doing various activities, but it can also be things like road sweepers and water bowsers, so things that are there to control dust and emissions off site. Yeah, which we'll be talking quite a bit about on this call. We also want to help minimize exposure to people within the site, so that's from a health and safety point of view. For those familiar with COSH, there are various limits. 8-hour time weighted averages and 15-minute spikes that employers have a duty to protect staff and keep within those limits. And then thirdly, at the same time, we want to deliver an OPEX return on investment. We want to save water and save fuel, which is great for the environment, and it's also great for OPEX budgets as well. Cool. So let's start with our air quality services. So this is our software platform, Atmo Core. This is what air quality looks like in our vanilla form. So before the works that we're going to talk about on this call. So you can see air quality around the site. This is looking at particulate matter at Bristol Temple Mead Station over the last 3 years. And so you can see you've got sources from trains, especially on these inner platforms, and the larger intercity trains on the outer platforms as well. But what the client wasn't expecting to find, and what was really insightful, was we identified where staff and personnel on site were at highest risk of exposure. So looking at around the taxi rank and the buses and the smokers area. So they actually were as bad for particulates as any of the trains were. And it's a much cheaper and quicker problem to solve. So that was one of the insights we delivered on this particular site. And we also do geofencing as well. Yeah, and we can do various flavors of air quality as well. So this is looking at silica monitoring. So as you can see, the HSE limits for silica are relatively low compared to general dust, because they're more harmful for those familiar with silicosis. And so yeah, so we can do different flavors of air quality, but whether it's particulates, NO2, silica, hydrogen sulfide, the goal is the same. We want to reduce, minimize exposure to people, and we want to minimize emissions off site. So I'm going to hand over to our lead developer on this, Finn O'Connor, who can, give a a little bit more about what we've been working on this project. So yeah, over to you, Finn.
Thanks, Guy. Yeah, thanks everyone for coming. Like Guy said, I'm lead developer, so I was sort of the technical lead on this project. And this is really great because I don't often get to go on a technical deep dive with people, but today I get to talk about how it works. Maybe Guy will have to give me a little thumbs down if I'm going too deep down the rabbit hole.
Go for it, Finn. Go for it.
So essentially, dust is a big issue in a lot of different sites. But the main point of this slide you're looking at here is that dust suppression can be quite inefficient if you're not using real-time data. So you can see what these green bars are is, on the left, you've got 10%. And what the green bar is saying is that only 47% of the time you had a 10% reduction in dust levels after that sprinkler event. So this is looking at some static dust suppression. And similar things apply to water bowsers. At Hinkley Point C, their dust suppression strategy is water bowsers that I'm sure a lot of you will be familiar with. They go around site and they spray water on the roads to stop, new dust being kicked up. But, having only a 10% reduction in dust is not a lot. And so about, over 50% of your water used is not doing much at all. So at this particular site, that leads to about 1 to 10 million liters of water. And that's a significant OPEX expenditure. Do you want to just go over to the next one, Guy?
Oh, yeah.
So here, it's a little bit scary, but I won't, don't worry, this won't be a mathematical lecture, but I'll try explain the key parts of how this solution works. So there's essentially 3 parts. So one is an IoT sensor network, and that gives you access to real-time data of dust levels around site. And there's also GPS sensors on all the water bowsers. So over the period of 6 months or so, we collected all of that data at Hinkley Point C, and then that feeds into the next piece of the puzzle, which is the digital twin. Now, the role of the digital twin is essentially to learn the relationship between bowser movements and dust levels. So this could apply to other sites as well. Say you were using water sprinklers instead of water bowsers. The role of the digital twin would be to learn, when I turn on my sprinklers, what happens to dust levels on site. And the reason that's so powerful is it gives you essentially a simulation of the site where you can test, hundreds or potentially thousands of different policies and learn what the best policy is for your site without real world testing. So once we've built that digital twin, we try and make that as accurate as possible. At Hinkley, we also included weather data. So we try and give this model as much useful information as we can. So not just dust levels and what water bowsers were doing, but also how sunny it was, whether it was raining that day, humidity, temperature. And once you have that digital twin, you then try and build an optimization model. So that's the next piece in the puzzle. And the job of the optimization model is essentially to come up with the policy. And its job is to learn how to be most efficient. So I won't go too much into detail about this training loop, but essentially the model we are using here at Hinkley, it's a deep reinforcement learning model, and you basically let it play inside the digital twin, doing thousands and thousands of different actions. And over time it learns, when dust is like this around site, this is where I should send my water bowsers. And the key thing here is that in sort of towards the right, you can see where it says reward function. So your optimization model, we choose what it is that makes a good model, right? And here at Hinkley, what we've decided is you want your dust levels on site to be below a certain threshold. So dust levels going above that is bad. If you are below that threshold, you then want to minimize your water and fuel consumption. So, that's quite good because you can prioritize safety first of all, and then given that, you can save money and decarbonize in the process. The output of that is it essentially proposes a route, given what dust levels are doing around site. And the way we've decided to send that back to water bowsers at Hinkley is in an email that goes to the bowser drivers. Now, that could also take any form. It doesn't necessarily need to be email that goes to a person. You could hook directly into a sprinkler system and have the optimization model turn on and off sprinklers given what the sensors are saying. Yeah, so I hope that sort of makes sense about how it works. And essentially, the key ingredient here is the digital twin. It allows you to test loads of different policies and then choose the best one based on what the data is saying, rather on human intuition, which can be quite inaccurate sometimes. Yeah, should we go on to the next guy? So this is just kind of a closer look of what the site looks like. You can see there's lots of different roads. So we split it up into, you can see little nodes and lines, and that's the technical term is the action space for you to take, but a browser can go along any of those roads, and so you can test in the digital twin, traveling on all of them and see what's going to happen to air quality on site. Now, the form that our digital twin takes in this case is essentially a forecasting model. So it takes in what PM is doing and what your water browsers are doing, and it tries to forecast into the future what dust levels are going to be. And so that's quite handy, because now in the email we can include, this is what your current PM levels are. If you follow this route, hopefully all those dots on the sitemap should go green. And do you want to go on to the next guy? So, Atmo measures a whole lot of different air quality metrics. At Hinkley, we're only looking at PM10 and PM2.5, but you could use a similar method to this one to look at a variety of different issues. So, if we can find a relationship between your dust suppression and silica, you could use silica data to make your optimization model. Similarly, if NO2 is your issue and you wanted to optimize when your HVAC system was turning on, we'd use an extremely similar method. And then I guess the ultimate sort of decision about when is it a good idea to use a digital twin is basically when you want to know what is a good policy, and you can measure whether that was a good policy or not based on some sensor data or any data, in fact. You build a digital twin that learns what happens with each different policy. And then in this case, we used a deep reinforcement learning model to make that optimization model. Doesn't necessarily need to be the case, but the reason reinforcement learning is so powerful is because it can take into account a cost. So anywhere where your action has an inherent cost, such as using water or using fuel, then a reinforcement learning model usually gives quite good results. Yeah, I think that's it for me. If you want to carry on, Guy.
Awesome, thanks, Finn. Yeah, super interesting. And yeah, like I say, it's I think a big challenge for industry is that these systems are bought, sprinkler systems, mobile dust suppression systems, often costing hundreds of thousands of pounds or millions of pounds, sometimes millions of pounds a year to run, and we're not optimizing these systems. So I think there's a huge opportunity here, yeah, like I say, we're already finding that on a large site that might be using 10 million litres of water a year just on suppressing dust, up to 70% of it can be wasted, i.e. not achieving that 20% reduction that we saw earlier in particulate. So yeah, we think there's a really big opportunity, and as you touched on, Finn, potentially in depot environments and built environments where there's HVAC systems, the same algorithms were. There's an energy cost, there's a particulate reduction gain, and can we optimize for that? So I think there's lots of scope for this to expand going forward. But yeah, I'll hand back to Kieran. Yeah, because I don't have any visibility on any of the questions or anything. So yeah, I'll hand back to Kieran.
Yeah, no problem. Thanks very much, Guy. Thanks, Finn. It's always really insightful. What like to do is I've actually got a couple of questions that I'd like to run through, just that will potentially just distill what we've been trying to convey in this session today, and potentially in a less technical format in some areas as well. So one of the questions that I've come up with, which is quite direct, but what are the key benefits of optimizing on-site dust suppression systems through a more intelligent and data-driven approach? Because obviously systems exist, and I know that we've touched on these points throughout the presentation. I'd just really like to distill that and make sure that that message comes across clearly.
Sure. Yeah, so I guess the main ones are, increased safety. It's really hard for a site manager to know what dust is doing all over their site unless they're keeping an eye on it constantly. Decarbonization as well. So if you can optimize your water bowser fleet, you're using less fuel, and then also return on investment. So if you're spending, millions of liters of water that's going to waste and, loads of fuel, that's a significant return on investment. And then also a good neighbor. If you can reduce your dust levels, you're going to reduce your emissions off-site. Something I could just expand upon is that first bit of, this does actually reduce safety. What we find is that if you don't have any way of measuring air quality and your dust suppression system is not hooked into that real-time measurement of air quality, you're essentially relying on human intuition, and site managers are busy people. What you're going to get is you're going to get a set of routes or a dust suppression policy that stays fixed in time, in stone, for 6 months at a time. And that doesn't allow you to respond to real-time changes. So today, this area of site might be really active and there's loads of dust there, but tomorrow it might be that area of site. Unless you have a full-time person thinking about that constantly, chances are you're going to miss that, and there's going to be, dust around site that you're not going to be able to take account of. Yeah, I think, does that answer the question? Hopefully less technical this time.
No, it's great. Yeah, it was really useful and insightful. Thank you. No issue with the technical side, but for someone like myself, it's useful to get that more direct explanation of it. I've got just a couple more for you here, Finn. So obviously there's a huge component around data capture. So how does the AI or the machine learning or the data analytics component ensure that we're optimizing suppression while minimizing resource use?
Okay. I think the key one there is basically it lets you test many, many different policies, which you would never really be able to do in real life. So, if you might say you had spot measuring, you might measure what your dust level is, change your policy on site, so how often your sprinklers turn on or something, and then you get another consultant down to do another spot measurement. And that can take months and months, and that's quite a lot of cost. Whereas this is constantly, every day, testing hundreds of different policies in the simulation. And so you can choose what is a good outcome for that policy. And in this case, it's I want to reduce my fuel consumption and reduce my water consumption. So it's that ability to test hundreds of different policies using the data that lets you come to a more efficient proposal.
That sounds fantastic. Thank you. But with all of that in mind, what level of training or expertise would be required to operate and maintain the system from anybody on site?
So luckily for people at HPC, none whatsoever, because we have, you might have seen in the presentation, there's that map, and that goes directly to water bowser drivers as an email. So in future, we're considering including it into the web app, and then, someone might need to know how to log in and view the map, and there might be some other KPIs there that they're interested in looking at. But I think the email is a good way that we want to keep going forward with, because, yeah, no training required whatsoever. Anyone can do it.
Great. And I think that's it from my side in terms of questions that I have over here. I'm not sure if there's any more questions from anyone else, but what we will do after this is we will send you all a copy of the recording for the webinar and also the slide pack, and you can feel free to get in touch with Guy, myself, Finn, to have any further discussions that you might have and that you might be interested in. Sorry, and we hope that obviously today's session has been insightful. And yeah, we look forward to continuing the conversation with you all, and would like to thank you again for your attendance, and yeah, appreciate you taking the time to join us today.
Great. Thank you, everyone.
Thank you, everyone.
Thank you, everyone. Cheers. Have a good afternoon.